All right, this is fun stuff right here. I don't care who you are, this is fun stuff. We're going to take a look at this parabola right here. We're going to put it in standard form, transformational form, where we have y's on one side, x's on the other, and we have things in groups, and you can clearly see what the vertex is going to be, all that kind of stuff. That's what we're looking at. Then we'll find all these pieces, do everything short of actually graphing the parabola, because, well, I graphed one in the last video, so if you really need to see that, go watch that video. But I like to find these characteristics without actually looking at the graph, so we can practice just being able to see the numbers and know what those things are going to be. So anyways, the main thing about this video is taking this to a different form. Okay, and what do we have to use to change this to be in a different form? If you remember back when we were dealing with quadratics, if we want to change something to vertex form, which what we're doing here is very similar to that, we had to use completing the square. All right? So, in order to complete the square, we do want to have the terms with x's on one side and terms with y's on the other. And I would go ahead and make it, if it's x being squared, I would make it y equals x squared, yada, yada, yada. If it was y being squared, I would make it x equals. And so first of all, that's what I would make sure it looks like that. So we've got y equals this. Now the first thing we have to do, if we are trying to complete the square, if we're trying to change this into our standard form, is we want to factor out that a value. I always think of it as the a value, because I think back to quadratics. We're left with x squared. 3 divided by a negative 1/4, because we're pulling that out. We're factoring that out of the terms with the x's. We're going to leave the 6 alone. But we have to pull out a negative 1/4. And 3 divided by negative 1/4 is a negative 12x. Okay? I always leave some space in my parentheses. I've always got space on the outside. But we had to factor out the a value from our terms with the x's. So now we're looking right here. You take the coefficient in front of the x, you cut it in half, you square it next. Negative 12 cut in half is negative 6. You square negative 6 to get a positive 36. But then we take that value, we multiply it times the a value, and we subtract that from the outside. We add it from the inside, but we subtract it from the outside. 36 times negative 1/4 is a negative 9, so we subtract a negative 9. You add whatever you get on the inside, you multiply it by the a value, and you subtract that from the outside. So we're subtracting a negative 9. What we have in the parentheses is a perfect square. What we have on the outside is now 15. We're still not, this is vertex form, don't get me wrong, if you're thinking quadratics, this is vertex form, but this is not our standard form when we're thinking about a parabola. We want to get the y, we want to subtract that 15 over, so we have y minus 15. And if you really look at that form, it always has 4p. 4p is always grouped with what's not being squared. If this is x minus 6 squared, we don't need the coefficient on this side. We want something like that on the other side. So to get rid of that negative 1/4, I'm going to multiply both sides by its reciprocal, which is negative 4. Negative 1/4 times negative 4 is a positive 1. And so we have negative 4 y minus 15 in parentheses equals x minus 6 squared. Here's that form we've been looking for. There it is. Right there. We've changed that to the standard form. Okay, now we need to identify some things. We need to identify the vertex the focus, the axis of symmetry, the directrix. Okay, what's being squared? It's the x is being squared. So we already know this is going to be a regular quadratic-like parabola. It is negative, so that means it was opening either up or down. This is definitely opening down. Okay, it's all good information for us. So this is opening down. This helps us get a picture of what we're thinking about. Our vertex, we can clearly see our vertex is 615. But then, oh, and we can also go ahead and grab our axis of symmetry. That we know, vertical axis of symmetry, it's going to be x equals the x coordinate of the vertex. This is typical quadratic-like stuff. But the focus in the directrix, all right, think about this parabola. It's opening down. You've got your vertex. The directrix would be going perpendicular to our axis of symmetry, so it's like this. The focus is going to be down here. All right. Now we need to know the p-value if we're going to get any further. So we take that -4, we set that equal to 4p. Probably do that in your head. P would be a -1. Well, in order to find the focus, we add the p-value to the y-coordinate. So our focus would be 614. Now, why do we add it to the y-coordinate? Well, we know because of what we see here is the x-coordinate's always staying the same. The x-coordinate's always staying the same. It's the y-coordinates that are changing. All right. So now we also want to deal with the directrix. The directrix, of course, is that line, and we have to subtract the p-value from the y-coordinate to get y equals, 15 minus a -1 would give us 16. Okay, so that would be y equals 16.